Hey guys, sorry I can't be there with you today. At this point, you should have completed your daily warm up, making sure that you read all of chapter 12.2 and then answered those 5 questions on it. And then the sub should have had an answer key for you and gone over the answers to yesterday's worksheet. And if there's any questions, we can definitely come back to that tomorrow. And then now we're going to just do a few notes, leaving off where or starting off where we left off yesterday. So yesterday we talked about kind of motion and speed and how we calculate speed. And remember, speed is distance over time. And we said that the average speed would be the total distance traveled over the total time it took. So even if we have a change in speed, because we don't typically go a constant speed, normally we're speeding up or slowing down, we can still find that average speed, right? And so we just said that that's the total distance traveled over the total time that it took. So we left off then yesterday at velocity. So we're going to talk about velocity today. And velocity is the speed and the direction of an object. So not only do we want to know how fast we're going, we also want to know where we're going, in what direction we're going. So an example of velocity would be an airplane moving north at 500 miles per hour. So I know that I have a speed, 500 miles per hour, and I have a direction, north. So any direction words, north, south, east, west, up, down, right, left, that is going to indicate that now I have velocity, not just speed, as long as it is coupled with that speed. Another example could be a missile moving toward you at 200 miles per hour, miles per second. So here I have the speed, and here I have the direction. It's moving toward me. Hopefully I get out of the way, right? So go ahead, jot this down. You can ask the sub to pause the video for you if you need more time. All right, so here's a question for you. What is the difference between speed and velocity? Well, we know that speed is just distance over time, right? So miles per second or miles per hour or meters per hour, or maybe it's kilometers per hour, because we said that was the unit. And then also remember, the unit is very important. Otherwise, we get lost with where we're at. Velocity, so that's just speed. Velocity includes direction as well. Okay? So velocity includes the speed and the direction. All right, when we take a look at graphs, it's pretty easy to understand speed. Okay? So here I have the distance over the time. So I have a speed graph, and I can tell the speed based on the slope of the graph, okay? And I'm not 100% sure if you've dealt with slope in math yet, but I'm assuming you have. I think you have. So we're going to talk a little bit more about this slope, okay? So the slope is the rise, so how much your line on your graph is rising over how much the run is. So the rise is going up and the run is going to the right, okay? Or in the direction that the slope is moving, okay? So I have a distance over here and I have a time over here. So the rise then, if I'm going from this point, and this is what's nice about slope, is I can select any points on the graph. If it's a constant slope, it's going to be the same speed. And we'll see something different in just a minute here. But if I pick 2 points on the graph, so this first one is 600 kilometers, okay, and the second one is 1200 kilometers, I would just take 1200 minus 600, so that's my rise, and 1200 minus 600 is 600, over my run. My run here, my first point would be 3 hours. My second point would be 6 hours. So 6 minus 3 is a total of 3 hours. So my rise is 600 kilometers. My run is 3 hours. So the rise over the run, 600 over 3, will be 200 miles per hour. Okay. So I'll say that again. I can take any 2 points on this line. I could go from here to here. I could go from here to here. But for our example, I chose this point at 600 kilometers at 3 hours. And then the second point I chose was 1200 kilometers at 6 hours. So I take the change in the rise, so 1200 minus 600, and I put that over the run. Or should she say the change in the run? So the change in the run would be 6 hours minus 3 hours. So that's 3. So 600 kilometers over 3 hours would equal to a speed of 200 kilometers per hour. All right, and here it is. 600 kilometers is my rise. 3 hours is my run, which would leave my speed to be 200 kilometers per hour. And you could go ahead and you could draw out that graph if you want. But what you want to remember is that the speed is equal to the slope. The slope is equal to the rise over the run. And I find that by choosing 2 points on the graph and finding the difference between the rise, and I divide that difference by the difference in the run. All right, remember, if you need our sub to pause, please ask him to do so kindly. We are going to move on to different slopes. So we don't always have this perfectly straight slope on a graph, just like we don't always go a constant speed. And that's what this is showing. So sometimes we have different slopes, okay? So we might have a runner who's running super fast and then they kind of hit their wall, and so they start to walk maybe, or maybe they just take a break and then they catch their second wind and they're going to go really fast. Well, I can break down their speeds based on the different slopes at the different points, okay? And I'm going to do it the same way that I found the speed for that constant slope. So what I do is I would just take the section where I see that it looks constant, and I would take 2 points, and I would find the difference in the rise, and I would divide that by the difference in the run. So here we're going up by 1 kilometer, and here we're going over in increments of 1 hour. So if I chose this point here and this point here, my rise is going to be 1 kilometer because I'm going from 1 to 2. And my run is going to be 1 as well, because I started at 1 and I go to 2, okay? So 1 over 1 is going to be 1 kilometer per 1 hour, 1 kilometer per hour, okay? Up here, my slope is going to be 0 because I don't have a change in the rise at all, and 0 divided by anything is 0, right? So if I see that I have a totally straight line here, I should say a totally horizontal line, my slope is going to be 0 because I have no rise. I do have a run. Time kept going, but that runner didn't go anywhere. And so I don't have a rise, which means that the slope is 0. Okay? So there's no speed happening here. Then I could find the difference here. And you can see that here. So I'm going to find the rise over the run again. The rise, it goes from 4 to 6. So 6 minus 4 is 2. So my rise is 2 kilometers. My run, I'm going from, it looks like 5.5 hours to 6.5 hours. See, that's going up by increments of 0.5 here. So 5.5 to 6.5, that's 1 hour. So my rise is 2 kilometers over 1 hour. 1 hour. So 2 kilometers per hour. All right, that's how we could find the different slopes. All right, so here's a question. Average speed is going to be my total distance over my total time. So now I don't have to break it down at all by the different slopes. The 2 points I would want to choose to find the average speed would be the beginning point and the ending point. And the reason I do that is because that's going to give me a look from here to here, okay, of the whole entire run, okay? So I would choose my rise. I know I started at 0, that's my first point, and kilometers. And I went all the way up to 12 kilometers. So 12 minus 0 is 12. So I know the total distance I went for this entire run, I shouldn't say run because for this entire time was 12 kilometers. Okay. Now I have to look at the run. Okay, this is in hours. It doesn't tell you that, but down here, this should be labeled hours. I started at 0 hours and I went all the way to 6 hours. So my first point was at 0. My second point was at 6. So 6 minus 0 is 6. So the total distance, 12 kilometers, over the total time, 6 hours, will give me the average speed of 2 kilometers per hour. Did my speed change in there? Absolutely it did. How do I know that? Because the slopes are different at different points. But from beginning to end, my rise over my run gives me my average speed, which would here be 12 kilometers per 6 hours, and I divide that out, would be 2 kilometers per hour. All right. Okay, a couple more slides. Question. What does the slope of a distance versus time graph show you? These are my distance versus time. That is going to show me the speed, okay? The motion of the object, how it's moving, it's telling me all about the speed. So the slope is equal to the speed. Speed is distance over time. That's why we get speed from a distance-time graph, all right? Lastly, here I have an example of 3 different runners, and I want to know who's the fastest runner. Well, it stands to reason that the person or the runner with the steepest slope is going to be the fastest because they are going to have the highest rise over run ratio. Okay, so if I see a steep slope, that is going to be moving faster than a lower slope because the ratio is going to be higher. All right. So what I want you to do now is go on to Google Classroom under the Classwork tab, Daily Lessons. I do have an assignment for you. It is the CK12 worksheet again. And it is speed and velocity. So complete that, work on it for tomorrow.